So I'm Vasudev. I have been working with Mercedes-Benz majorly as a deep learning research engineer, and my expertise are mostly around vision. So I have been working with, let's say, vision related use cases, right? So today, let's maybe go ahead and see what deep learning can do for us. So maybe let's start maybe with a small set of questions. Like, feel free to unmute yourself and answer. So can one of you tell me the difference between, let's say, AI, ML, deep learning, right? Anyone? Or are they pretty much the same? Or maybe let's start with what do you guys think when we say the term AI, right? So what do you think like AI is?
According to me, these are different terms. Basically,
Mhm.
AI is the umbrella term under which machine learning and deep learning are the other parts of it.
And what is AI? Like what do you understand by AI? Anyone?
Augmented intelligence.
Sorry, like I think Sneha, you were saying something, right?
I was just saying that it's augmented intelligence.
No, like what do you mean by it? Like, so when you hear that term AI, like what comes to your mind? For instance,
That a machine which mimics human intelligence is.
again. So what I'm saying is like, hey, be a bit more creative. Be like a 4-year-old child, right? So for instance, when I hear AI, right, the first thing that comes to my mind is maybe Jarvis, right? Whether it's possible, it's not. That's different, right? So when you hear AI, right, what comes to your mind?
It means it can provide solution to anything and everything
Mm-hmm.
that human intelligence is not capable to think or think of.
So I would not say like human intelligence not really capable to think of, but more like aiding us in doing a lot of things that we can do, right? And we'll see like one of the examples today along the same lines, right? So
Yeah, creative solutions.
So this is like a intelligence which is not natural. We formed it. It's not natural. So it is artificially we formed. That's why it's
A kind of a
artificial
aid,
intelligence.
a kind of a aid that will ultimately help the humans to have proficiency in their work.
so do you think like artificial intelligence will take over the human world and like throw us over? There has been like a bunch of articles, bunch of citations around ChatGPT saying that yeah, it'll take over the world. Different LLMs, for instance. So what do you guys think?
Indeed, sir, it is a very controversial topic nowadays that AI will take the jobs of human.
Mhm.
But sir, I believe that humans have made this, so I don't think so. It will take over the humans.
Okay. Anyone thinking that it will take over us?
Uh, okay, my perspective. Hi, Vastev. My
Mhm.
name is Kavita. So, it's a very interesting document I read about,
Mhm.
ChatGPT when it just the latest version which made a boom. Nobody recalls the previous hard work these people have put in into to create something so humongous. So, anyways, it was a very beautiful line. I think it describes better when it comes to job security pertaining to AI that when calculator came, uh,
Mhm.
calculator didn't replace human. Calculator replaced people who could not use calculators.
Mhm.
So basically, humans were replaced by people who could use calculator, right?
Yep.
So similarly, AI, when it comes to AI, if you can use it, if you
Mhm.
can, use it for greater good, maybe discoveries or efficiency level or any dimension.
Mhm.
So if you are good at it, I would say, yeah, you can replace other human who could not use that. But there is no way like standalone. I don't see it right now, as
Mhm.
of now, because I'm following up very diligently. So I would say not right now, but yeah, that's
Mhm.
my take on AI, understanding of AI.
Interesting take.
I believe it can take control over the labor work via the machine work.
So like
Yes,
automating basically
yes,
a bunch of
automating machines or
yeah.
labor work.
So yeah, that's like a good application area. Anything else that comes to anyone's mind before we get started with like the boring part of the session?
I just remembered of an interview I saw recently. Like,
Uh-huh.
I heard that interview, and I don't exactly remember of whom it was, but he compared the rise of AI at this age
Mhm.
to the automation and the industrial revolution that took back several years ago. Like how people were scared that machines will take away their jobs, and now
Mhm.
people are scared AI will take away their jobs. So it was just a comparison that was made.
Mhm. Mm. Okay, perfect. So I think then what we are gonna see in this session is like, so we are not gonna like build anything, right? Because there are a lot of people building a lot of good things out there for us, right? So what we'll be doing is we'll be using something called as a X-ray vision. So this is a library built out in PyTorch. So have you guys heard the time right of term PyTorch, right? And it's not like a new random term for you guys, right? Yeah, just heard it somewhere. Okay, so basically PyTorch is a Python library, right, which we mostly use. So like you have TensorFlow, you have Keras, you have PyTorch, you have like a bunch of libraries that you can use to build your deep learning stuff, right? Because at the end of the day, you won't be building, let's say, how to say, like the deep nitty-gritties when we say that writing a forward pass or a backward prop, right? So in that sense, we'll be using something that is already there. Like we'll be loading a bunch of pre-trained models. We'll be doing classification on, like Alok already told, like we're using the NIH chest X-ray images, right? So basically, we'll be doing classification on these, right? We'll be also trying to see like if we can do a bunch of segmentation and segment out different part of the image, right? Because if you have these parts segmented out, then this can also help you in easily diagnosing other things, right? So let's get started. So I am gonna use Google Colab, right? And I hope you guys are able to see it. Mhm. And now, if you guys want to follow me, like you can also, I would say, like just open up a quick tab of how to say mhm, Google Collab, and I'll quickly share a link with you guys, right? And you can copy this data set and start playing around. Like it is generally hosted over torrent, so that will be like a bit difficult. So I have just uploaded it to my Google Drive, right? So you can use this link to download the data, right? After the session, I think I'll also share the Collab file with you, but let's get started, right? Mhm. Perfect. Okay. So you guys can see the screen, right?
Yeah, also screen is visible.
Okay, perfect. So I think as someone rightly pointed out, artificial intelligence basically means an intelligence which is not real, right? Which is made by us. Now this could also be like an if-else loop where you are playing a tic-tac-toe game, right? For instance, you can just try if else, and that's also AI, right? Because at the end of the day, it's machine playing against you. Then after that, we have like, but now we have like artificial intelligence in more sophisticated sense, right? So then we have like within artificial intelligence, it's machine learning, where we have like small data, where we try to majorly use statistics and use it to make, let's say, various hypotheses, right? And then comes like deep learning, where we say that yeah, we're gonna exploit data, right? So basically, what is deep learning? Like it is one of the machine learning techniques where we use data to learn feature representations on its own, right? So why deep learning? Like so when the amount of data is increased, machine learning techniques are insufficient in terms of performance. One way you can understand is that machine learning techniques are very how to say very I'm looking for the right word, very efficient, or like very low powered, right? So when you have a lot of data, they don't have that ability to learn it efficiently. So this is where like deep learning comes in, where you have like a huge amount of layers, a very deep network, so you can like actually extract out these representations, right? So for instance, pretty much like the output and the input is the same. Like what changes is this network that we are putting. So like in a small MLP, we have like a very small network. In deep learning, we go for like multiple layers, right? So any questions till here, I would say, right? Because like this is a bit important, like before we go forward.
Vasudev,
Mhm.
what file you shared with us?
Mhm.
What is this file? Because it's still downloading. So
Yeah.
it's a huge file.
So
Is
this
this your
actually,
presentation
no, this is the
or
data set
something?
that I'm using.
Okay, okay.
Yeah. So let's say if you guys want to play around after the class, I'll also be sharing this notebook. So you can play with it. So it's around a 2 GB data set. Like it has images, like we'll come to it. Yeah. Okay. Okay. So then moving forward, what you see on your screen is basically like a typical cycle. Like how it goes is we first have training data, right, or training code, right? So once we have the data and the code ready, we start building, like we start figuring out the models. Like there is actually one phase before this, which is not actually mentioned, is which also comes here, is the research phase. So you have to like go around and based on your data figure out what models work best for you, right? So you cannot just go and blindly pick any model and say that yeah, it should work. So you have to do like a bunch of literature survey, figure out that okay, for this problem what model is already available. Once you have that, like you start trying 3 4 of them, right? And then you evaluate your model based on your matrix. Like for instance, for classification it could be accuracy, like like how accurate is your model in the task you have given it. Okay. Then once this model evaluation is done, right, then you put it to production, you do test, you deploy it, you do a bunch of monitoring, right? So this is the full life cycle. So what we are majorly interested in is building the models, right, which we are not doing right now. Here, what we'll be doing is we'll be taking the productionized or like the trained models. We'll be taking pre-trained models and we'll be just trying to do a bunch of things around it, right? So yeah. So any questions around the model life cycle or any questions so far?
Yeah, hi Vasu, it's Alok here.
Mhm.
Yeah, hi. Vasu, can you please, for the sake of the audience, can you please throw a little bit light upon the word pre-trained model? Like, what do you mean by pre-trained
Mhm.
models, and how it is useful in the field?
Yeah, okay, perfect. So basically, you know, like how we have like a bunch of great people out there doing open source things for us, so we don't have to do everything, right? So basically, like there are a lot of people who have train these models for us. So for instance, let's take like today's class, right? So what we want to do is we have these bunch of chest x-ray images and we just want to segment out different parts, right? So where is right? So now what happens is one way is you figure out, okay, where is the data? Oh, I have the data now. What you can build your own model, you can train it, right? And you can see. Another way is that okay, there are like people who has already gone through the pain of doing all this. Now what they have done is they have done this and then they have released the model. So they have already trained this model. So this pain part of taking the data, figuring out what to do, right, which network to use, then training it. So this part is already done, and then there is a model which is already available, right? And we are going to use this model today. So that's what we call a pre-trained model, like someone already training a model for you. I'm hoping, right, you guys are able to understand
Yep.
things, right? And it's not just totally going over your head. मतलब अगर ऐसा है तो we can always like repeat things over, क्योंकि there is no point going forward without like you guys understanding क्या अभी तक क्या हुआ है.
Guys, feel free to interrupt and ask question at any moment of time. Okay, if you're not able to understand. Yeah, so I think we can go ahead.
Okay. Else I'll start asking questions, so that will be like this.
Okay. Oh, bilkul, yes.
ठीक है. Okay. So then let's going forward. So what we use is we use a library called Torch X-ray Vision. So I have already installed it, but if you want to install it, you can just do like a pip install Torch X-ray Vision. So like a bit about this platform known as Collab, right? So just maybe I'll quickly open this for you. So you can just go to Hello Collaboratory and you have like this Google thing which they already have like a notebook for you where you can just start coding. So I'm using this, right? They have the libraries and everything installed for you by default. So right, all you have to run this and they take care of all the dependencies and all. So in that we don't have to have anything running or any code setup ready as such. You can just go to Google Collaboratory. I'll also like put the link in the chat. Oh, okay, I think you guys are not able to see, but yeah. So basically you can go to this link and you'll see like a Jupyter notebook opening up for you. Okay, moving forward. So once we have this, then we do a bunch of these imports. So we have NumPy, we import Torch X-ray Vision, we import PyPlot for plotting, and then we include PyTorch and Torch Vision. Right, so we do a bunch of imports. You guys are familiar with Python?
No, so I don't think so.
No, sir.
Okay, no, right. So then this like it's gonna be like a very high level walkthrough, right? So this is basically I'm just importing a bunch of things which will help me do my thing, right? So once I have imported this, this is the data set which I have already unzipped.
Yeah,
Right?
Vasu, can you just take 1 minute? Hello, hi. Hi, Vasu. Yeah, sorry, just to interrupt you. Yeah. So guys, let me tell you here what do we mean by this importing NumPy and all. So yesterday when I was teaching you R language, okay. So I showed you basically like when we are doing the R language that a lot of functions are already made. Okay, the very general kind of the things which we usually have to do. People who are experts in their domain, they just try to design a lot of functions associated for a particular task, put in a particular file, and then they submit it as a package. So basically, package is a collection of a large number of the functions. Okay. So in the R, when we were like using yesterday biostring package or like library, if you remember. So I was calling library biostring. Okay, why was you calling that? To read the file and then process the file, performing multiple sequence alignment and all those things. Okay. Similarly, in Python, which is again a programming language. Okay, so and program Python is basically considered as the programming language of data scientists. Okay, so here again we have more than 1,000 of packages specialized for the data scientists, and few of those packages are these basically. Okay, NumPy, Torch, X-ray Vision, Matplotlib, SkyImage, and all which Vasu is introducing. Okay. So in order to analyze and perform all those things, you need to call these packages, which we will be basically making use of. Am I right, Vasu? Hello. Vasu, you got to mute, I guess.
Yeah. Okay.
Yeah,
so,
am I right?
yes. So then I think, yeah, then I will continue, right?
Yes.
So then like I just load the data set, right? So when I say data set, it's basically like a collection of an image. And what's the problem with this image, right? So is everything fine? Or so for instance, like what this data set contains, it's just I just do like a, so this is these 14 categories that Alok was talking about, right? And it also says that how many of them are positive, negative. So for instance, if I take edema, there are around 1 lakh samples which are negative and around 2000 samples which are there, right? If I take hernia, around same, like we have 227 positive samples. So this is basically like the distribution, right? Then what we are going to do, as I told you, like there are a bunch of great people out there who has done this networks for us. So we are going to use something called as DenseNet, where you have like these layers stacked up connected to each other, right? So just think of it like a black box for now. We load that network. So this is for something that we say classification, right? When we say classification, okay, all of you are comfortable with Hindi, right?
Yeah, I hope so.
Yes, sir.
Yes.
Yes, sir.
ठीक है, perfect. तो classification is basically करते क्या हम लोग कि we take an image और हमने बोला कि भाई मेरे पास 14 क्लासेस है या 12 क्लासेस है या 13 क्लासेस है और मुझे बताना है कि फ्रॉम विच क्लास दिस इमेज बिलोंग्स टू. अब जैसे कैट वर्सेस डॉग सुना है, राइट? कैट वर्सेस डॉग पता है कि एक मेरे पास कुत्ता है, एक मेरे पास बिल्ली है. अब मैंने एक नेटवर्क को बोला कि भाई दिस इज हाउ अ डॉग लुक्स लाइक, दिस इज हाउ अ कैट लुक्स लाइक, और मैंने बोला कि अब तू सीख, राइट? सो आई मैंने उसको इमेजेस फीड की धीरे 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 एंड एट वन मोमेंट उसने सीखना सीख लिया कि लाइक व्हाट द कैट लुक्स लाइक एंड व्हाट अ डॉग लुक्स लाइक एंड हाउ डज इट डू इट, डिफरेंट डिफरेंट फीचर्स, राइट? कि द शेप इज डिफरेंट, लाइक द फेस इज डिफरेंट, उस टाइप से. तो सिमिलरली फॉर आवर चेस्ट डेटा सेट देयर आर दीज 14 different disorders, right? और problems that could exist. तो basically हमने network से बोला कि भाई बता दे मुझे क्या करना है. Second that we do is a PSP net or a pyramid pooling. What it does is like it takes every pixel. ठीक है? So what is pixel is कि हर image का like each point is called a pixel and it would try to tell you कि what it is. जैसे ये दिख रहा है, right? ये के background है, पेड़ है, इंसान है, right? So what it is. And this is also what we'll try to do with ये वाला image, right? We'll try to figure out different parts of this, ठीक है? कि जैसे left lung कहाँ पर है, right lung कहाँ पर है, and things like that, right? ठीक है? तो अभी मैंने यहाँ पर classification के लिए एक network load कर लिया, which is already available, ठीक है? यहाँ पर फिर मैंने एक segmentation के लिए network load कर लिया. ये classification में class बताना है, segmentation में हर एक pixel के बारे में बताना है. अब मैं क्या करता हूँ, मैं डेटा सेट से एक रैंडम इमेज उठाता हूँ, राइट? जस्ट टू शो यू गाइस कि हाउ माय डेटा सेट लुक्स लाइक. सो दीज आर सम इमेजेस, ठीक है? अब जैसे फॉर इंस्टेंस एक और, राइट? तो आई एम जस्ट लोडिंग सम रैंडम इमेजेस फ्रॉम द डेटा सेट जस्ट सो यू कैन अंडरस्टैंड किस टाइप का एक्सरेज अवेलेबल है हमारे पास, राइट? एक्सरे तो सबने देखा होगा, राइट? सो यू गाइस आर अवेयर कि व्हाट एक्सरे आर, ठीक है? अब जैसे मैंने ये वाला ले लिया फॉर इंस्टेंस, तो अब इस वाले में we know that there is some infiltration, right? Because मेरे पास labels भी हैं. Then I take this classification network, मैंने इससे बोला कि भाई तू बता क्या दिक्कत है. So then it will predict some numbers for everything. उसके बाद फिर coming to segmentation, right? जहाँ पर अभी जैसे let's show you. तो अभी जैसे what you see is कि when we train a network we also need to know कि भाई information कहाँ से आ रही है, right? कि मतलब where the left lung is, where the right lung is. So this is how the network was trained. कि अगर यहाँ पर if you see, right, that this is my left lung, this is my right lung, ये मेरा left hilus pulmonis है, this is my heart, this is my aorta, right? आप जैसे ये अलग अलग, तो अब इस पे network trained है, ठीक है? But training वाला part is already done for us. What we do is हमने segmentation network को ये वाला image दिया है and we asked this कि भाई can you tell me like what are the different parts, and this is what we get. जी जैसे देखो सब segment out, okay? आ गया इधर. जैसे ये left clavicle है, एक second.
Now somebody has raised a hand.
Yeah, I see like a bunch of you. So yeah, Tanya, please go ahead.
Yeah, hi Tanya, are we audible to you?
Okay, I think like we'll move
I
forward.
guess it was your mistake, yeah.
Mhm. Yeah. Okay, so basically, like if you see here, right, I'm able to figure out where my left cervical is, where the l- right one is, where is the left scapula, right scapula, left lung, right lung, right? So this is all given by a model which was already trained. So right, so now if let's say you are a doctor or someone, right, or if you're assisting a doctor, then you can always like just segment out and figure out like okay everything is fine or not. You can always run statistics on top of these that okay is there some deformation here, is there some problem. So right, so this is basically like what we can do with models that are already available, right? And you are seeing that I'm running it just. So for instance, if I just change the image now, right? So this is a different image, and all I have to do is I just have to run it again and use you. So basically, like you see things getting printed out, and yeah. So basically, the model was running here, and you see like all the segmentations now here again, right? So this
Uh,
is. Mhm.
Vasudev,
Yeah.
Tanya is trying to ask what
Huh.
is a segmented network?
Huh.
Probably there is a problem with her
Okay.
audio. Yeah.
Uh-huh. So we are
She has
using
written
like
in the chat box, what is segmented network?
yeah. Okay. Mhm. Okay. Perfect. So basically, like if you see here, what we mean by segmentation is that if I have an image, right? Like I say, let's assume कि let's leave medical imaging for 1 second, right? ऐसे सोचो कि you want to count people going in and out, ठीक है? तो अब इसमें what you can do is you can figure out where a person is by saying कि I'll want to know कि पिक्सल 00 पे पेड़ है, आदमी है, बैकग्राउंड है, साइन है, क्या है, राइट? सिमिलरली फॉर पिक्सल 01, पिक्सल 02, तो उस तरीके से व्हाट वी टेक इज वी टेक एवरी पिक्सल एंड वी वांट टू नो व्हाट इट इज, लाइक बैकग्राउंड है, वेदर दिस इज अ पर्सन. So this is a problem which we called as segmentation. Coming to the net, हम लोग we use a CNN. What we do is कि first we feed the image, it goes to a bunch of layers which we call it as encoder. It comes to a feature map. From feature map, what we do is that we pool it at different sizes, then do convolution, and then we like concatenate it again. So this is more like a pyramid pooling module where we pool it at different sizes to learn information at different scales, and then like concatenate it back right after upsampling, uh, and then we convolve it again, right? So this is what like the network architecture is. And when I mean what segmentation is, it is basically the her pixel pe we go in an image and ask the network ki what it is, right? So there are fixed classes. जैसे हमारे case में what happens is that we have these 14 classes, right? Fixed. तो अभी जैसे chest X-ray में like there could be only these 14 things. मतलब ऐसे हवाई जहाज नहीं आ सकता, right? So basically this is what we do कि we ask the network कि अच्छा मुझे ये बता कि like what is this pixel, right? This pixel specifically, and then it will say that this is a left lung or this is the right lung, right? In this case, so this is what we do the network to predict कि भाई हर pixel पे मुझे बता दे what it is. So this helps us in understanding कि like is there some deformation. जैसे I know that generally how a left lung should be. अगर मैं किसी का left lung puncture है, right? So then this will be like something like a very deformed thing. जैसे for instance, so उससे we can always figure out. Did I answer your question? Yeah, Vaibhav.
हेलो सर, मैं पूछ रहा था कि जैसे ये लेफ्ट लंग आपने बताया कि अगर इसमें कोई डिफॉर्मिटी है तो उसमें पता चल जाएगा, तो ये नॉर्मल इमेजेस भी बताता है कि जैसे नॉर्मल कंपेयर करेंगे तब पता चलेगा ना, जैसे कोई लेफ्ट लंग है वो नॉर्मल कंडीशन में कैसा होना चाहिए और वर्सेस जो अभी करंट कंडीशन है
हाँ.
तब वो डिफॉर्मिटी पता चलेगी, तो ऐसा कुछ होता है जस्ट जो करंट सिचुएशन है वो सिर्फ वही बताता है?
नहीं तो देख जनरली होता क्या है कि इस नेटवर्क को ना तू ट्रेन करता है, ठीक है? तो जब ट्रेन कर रहा होता है, जैसे फॉर इंस्टेंस जैसे जो तूने बोला कि लाइक नॉर्मली फॉर अ डॉक्टर और किसी के लिए भी दे ऑलवेज हैव अ रेफरेंस कि एक्चुअल लंग ऐसा दिखता है, राइट? उसी
Yes,
के
sir.
बेसिस पे जैसे देख भाई नॉर्मल नहीं है ना? तो मॉडल के लिए भी सेम है, मैंने उसको बहुत सारा डेटा दिखाया कि भाई लाइक द प्रॉपर लंग ऐसा दिखता है, अगर ये वाली डिफॉर्मिटी है तो ऐसा दिखता है, ये वाली डिफॉर्मिटी तो ऐसा दिखता है, इसीलिए वो हर एक को आइडेंटिफाई भी कर पा रहा है। अगर मैं उसको सिर्फ डिफॉर्म लंग्स दिखाता तो वो सही लंग्स कभी आइडेंटिफाई नहीं कर पाता, क्योंकि उसने कभी सही लंग्स देखे नहीं है। तो जब मैं मॉडल ट्रेन कर रहा हूँ या जब इन लोगों ने मॉडल ट्रेन किया है तो उसको परफेक्ट लंग्स, उसको डिफॉर्म लंग्स सब दिखाया गया है।
ओके ओके सर, थैंक यू।
Okay, so Vasudev, can I understand it as like it has also data of many type of deformities in the lung, and so when you have trained a model like this, so and when you give your X-ray, so probably it will be able to say that there is uh, either this deformity or that deformity. That also it can, instantly tell us because it already has a data on different type of deformities in lung. Is that so?
Yes, ma'am. So for instance, if you see here, right, that we also have a network which is predicting that which kind of deformity it is, right? So this is just predicting it based on the image, right? Just so that we didn't take a very big network which is also taking segmentation. So this network is directly taking the image and trying to predict what deformity it has, right? And you can also see it giving different probabilities to different classes, and then we can always club it with segmentation, for instance. So yeah, but this network is like directly also telling you that what deformity it is just based on the image. But segmentation is always more robust because we are dealing with each and every pixel, so the chances of errors are slightly, or like I would say significantly less when we do segmentation versus when we are doing it with direct classification. So that's why with classification you'll also see some errors at times. Isliye like we prefer segmentation always. But yes, so this is how it happens, that it can tell that which deformity it is. Yeah, so I think like this was pretty much it from my side, just to show you guys that abhi, like at this moment there are like a shitload of tools available, right, which you can use to uh, like just get information out of things. Like just say you can have X-ray segmented out, you can have models which will tell you, okay, this is wrong, that is wrong. You have like a lot of data sets which are publicly available. So just like you're free to play around. Yeah. So yeah, over to you, Alok, and open for questions.